Hello everyone, this is lecture series 9, Computer Networks Lab, dealing with the ninth experiment, that is the part B experiment. Please do like, share, subscribe and comment. So in the last series of video, we have seen about bit stuffing, character stuffing and the algorithm that calculates the distance between each of the nodes. And in this video, we are going to see about Dijkstra's algorithm. This algorithm is used for finding the shortest path between the nodes. So as we saw, if there is n number of nodes connected to each other, and if one node wants to transmit any data to the any other nodes, there may be n number of paths that can follow. So now this algorithm is designed to make the system efficient. That is, that particular node which is going to send the data is going to assure that it is going to choose the shortest path. Even though there are 4 or 5 paths which it can transfer the data, it is going to choose one path which is the shortest path. Okay, so for that you're going to accept the input and output, and infinity is defined as, that is the infinity distance, the distance between from one node to the other node. We are giving it, we are accepting all the values. So the highest value what we are accepting is 9999. Okay, so now max 10, you are defining max 10 is, so the maximum number of nodes or maximum number of paths that we are accepting is only 10. So we are limiting here. And void digital, now you are going to give the algorithm a condition. So int g max of max. So here you are framing the matrix, that is the max value that can be taken, and in int n and the start node. So now after going to the main program, here int j of, that is here this is the algorithm, and you are going to take the maximum nodes, that is maximum path that is available for each of the nodes to transmit the data, and you are going to assign I, j, n, u, all these, because you are going to put all these into a loop. So now print enter number of vertices. So vertices is nothing but the number of nodes that has been formed at each area. So you're going to enter that you're going to read it here and print it, and enter the adjacent matrix. So if for each of the nodes, if node 1 has adjacent node as node 2, then you're going to enter that particular node matrix in form of matrix. That is, from 1 to transfer the data to 2, I can take what all paths. So that is adjacent matrix. I is equal to 0. So for that you are going to put this loop where you are going to assign the adjacent values. How this adjacent value is, you are going to put that in loop and read it out in form of matrix G of I j, right? And now you are going to print the starting node, entering node or starting node. So if you have 5 nodes for example, and 1 is my starting node, you are going to count the adjacent matrix from node 1. So node 1 to 2, 1 to 3, 1 to 4, 1 to 5, or 1 2 3 5, 1 2 4 5, like that. You're going to count based on what all paths available. So starting node will be the first node, that will be read here. And Dijkstra's g comma n comma, so starting node, the ending node, and the matrices that is formed, all those will be defined. Okay, now void Dijkstra's int, you're going to give the maximum possible distances, and you're going to give the starting node, and you're going to determine the path for that starting node. So now here int cost max comma distance. So here you are going to consider cost, where that cost is going to define which path you are going to choose. Say suppose you are giving a condition g of ij is equal to 0. Then if it is equal to 0, then that particular path will be taken. If not, the next path will be taken. So that is why you are defining this cost. Then the distance, so obviously you will be measuring the distance. And prediction, so you're predicting, you're not going to give the shortest path, you're just predicting the number of paths that is available. So all those you are initializing. And now int visited max, So now when you're assigning the path, you're going to determine that particular node, which all node it has visited to form a path, that count and the minimum distance for that particular node, and to the next node what it is the value I comma j. So here I comma j, you're going to put it in loop. You're going to check which all is taking maximum path, which is taking minimum path, what all the nodes that is covered, all those you're going to see it here. And if g of I of j is equal to 0, then if it is equal to 0, then you're going to assign the value as infinity. So 0 means you're going to assign a value infinity. What is infinity value? We have already assigned it as 9999. So that value are going to assign. Else, if it is not 0, then you're going to assign the value that is formed actually. Then for I is equal to 0, I lesser than n, I plus plus. Now you're going to calculate the distance. You have defined the node. Now distance of I is equal to cost of start node into I. So distance of I is, if you are taking the first node, then which is the start node and the node that you are calculating. So that will be your value. And for prediction, you can predict anything as start node and visiting as any node. And so the distance between that and distance between the start node which is visited and which you have considered the real one. So is equal to 0 is equal to 1. Now count is equal to 1, then while count is lesser than n minus 1. So when the count is lesser than n minus 1, then you have to calculate the minimum distance. So that is the count is n minus 1. So obviously it is the minimum distance that you are referring. So the minimum distance you will be giving the infinity value. And again, if distance of I is lesser than the minimum, so minimum distance you have assigned, and if suppose the distance that you have calculated is lesser than that minimum distance, then you have to again go for the visited node, whether some other path is available or not. So if suppose if it is available, then you will be defining that minimum distance to the distance available, or you will be going to the next node. You will be visiting the other node. One node is already over, start node is no over, visiting node is over. Then you again put into loop, you are going to see whether it is visitor node or starting node, which is the shortest path. So all these again you will repeat all these data for all the nodes, and then you're going to give count plus plus. So for each and every node you're going to calculate. Okay, now finally printf distance of node will be determined as distance of I which is taken place. So from which path it is coming, what is the predicted value, what is the original value that you're going to print, which is the whether it is equal to the starting node that we have calculated. So all these will come, and finally you will be getting the output in the terminal ./a.out. After typing this, you will get this word, enter number of vertices. So 5 nodes you are going to consider. So for that you are going to derive this adjacent matrix by finding the paths, and you are going to enter the first node. Starting node will be 0. So distance of node 1 is equal to, it will start telling 10 means, so path 1, what is the path 1? It is 0. Path 2 means 230. So what is the distance? Path 3 means what is the distance? So like that you are going to calculate, and out of this it is going to calculate which is the least. So distance of node 1 will be the least. So 0 to 1 will be selected by your Dijkstra's algorithm. Hope you have understood the concept. Please stay tuned for more information. Thank you.